And welcome back, Mindsetters. I hope you had a nice little break there and you went and did whatever you had to do. You went to go answer the phone, you went to go put down the phone, you went to go take out the laundry, whatever you needed to do. Make sure that you're now paying 100% attention because this section is pretty tricky because I know you guys have been asking me, is there a challenge question? Is there a challenge? No, there's no challenge question. This entire section is a challenge. So on that note, Mindsetters, pay attention, make notes, put your pens and pads out there, and write this stuff down because I know you got exams coming up soon. But on that note, this is where I hand over to Natasha, who's going to take it away.
Yes, so it is a challenge, but it's not a challenge that can't be beaten. You guys, if you just practice enough, and I know I say this with every single section, but if you practice enough, you will get better. It's one of those sections that makes sense when you do it correctly. And the only way to do it correctly is to practice, practice, practice. So we took a break halfway through the first question just because it is quite long. So I'm just going to quickly recap what we've done. All right, we had to find AC in triangle ABC. We knew that AD was given, angle B was given, side BC was given, and that little angle B was given as theta. All right. We then found side AB, which is the linking side between the two triangles. It links the one triangle to the other. That then helped us to work in triangle ABC and to find and to show that AC was equal to y times the square root of 1 over tan squared theta plus 1 over tan theta plus 1. Now, in a test situation, even if you couldn't show that, so you got completely stuck and you got stuck halfway, even if you can't show that, because if you look at the second part, they give you values for y and theta. Take the first part. It has already been, you know that that's what the answer is supposed to be, even though you didn't get it. Just take that first part and use it to help you answer the second two. Okay, so guys, please, I often see like in a test, people will get stuck at the first one and then they won't just carry on with what they were supposed to be showing. So if they asked you to show something and they gave you the answer, use that, okay, to help you do the second part, because there usually are hence questions in this kind of section. All right. Okay, so let's move on. We are given that y is equal to 15 and theta is 22, and they ask us to find AC. So that's just simply a matter of substitution. Okay, so I'm just going to substitute the values in. So therefore, now this is part B. We know that y is 15. So we put that in, and theta is 22. All right, and then we're going to use our calculator to help us. So it's 1 over tan 22 squared plus 1 over tan 22 plus 1. All right, and you're going to put that entire thing into your calculator. You'll find that a question like this will probably not go for more than 2 marks because most of the work's actually going to be done on your calculator. All right. Oopsie, and I think I've caused ink layers, which is usually my problem with this calculator. There we go. Let's see if this works now. There we go. Okay, so we're going to type in, it's the square root, and it's 1 over tan squared 22, so I'm going to use the fraction button, and it's 1 over, in brackets, tan 22. Guys, just make sure you close all your brackets or you'll get errors. And that entire thing in the denominator is squared. All right, then we're going to say plus another fraction, 1 over tan 22. All right, and then the final term there was a 1. We say plus 1. Okay, and then we hit equals, and it gives us that answer 3,09857 and all those other fancy decimals. So then we times that by 15, because that was the value of y, and we get an answer of, and if I round this off to 2 decimal places, it's going to be 46,48. So it's 46,48. and that is the value of AC. All right, so we know that AC is 46,48. If they don't tell you how many decimal places, we usually do it to 2 decimal places. All right, so we've got the value of AC. They next ask us to calculate angle ADC. So let's have a look at the diagram. Angle ADC, so that's that little one there. All right, and guys, please, once again, I have to remind you, don't work across planes, okay? It's going to get you into all sorts of horrible trouble. You need to work in triangle ADC now, okay? You can't work across the planes to try and get to angle ADC. We've got to work in triangle ADC. That triangle is 90 degreed. Okay, we can see there's a sign there saying that AD is perpendicular to AC. Therefore, we don't have to use the sine and cos rule. Okay, if you've got a 90-degree triangle, it's always easier, well, not always, but most of the time it is easier to work with the 90 degrees. All right. We know that side AD is 15, because now they've told us what Y is. We've worked out that AC was, what was it again, 46,48. All right, and we are looking for that angle ADC. So if we look at triangle ADC, what we've been given is 15, right, which is adjacent to the angle we want, and the side that we've just worked out, AC, is opposite. Okay, you can see it's opposite the angle. So therefore, we've got opposite over adjacent. It's a 90-degree triangle, so I can say tan of the angle I want, so this is now part C, tan of angle ADC is equal to opposites, which was AC, over the adjacent side, which was AD, which was 15. Okay, so I've set it out as AC over AD. We know what AC is, we know what AD is, and then obviously grade 12s, if you were paying attention during Dina's lesson with the grade 11s, she did all of that stuff and revised trig equations. That's what we're going to do now, okay, because we're going to end up with a ratio which we can use to help us solve for angle ADC. Okay, AC is 46,48. You wouldn't use the rounded off version in your calculator. It's going to give you a slight error, okay, about maybe, you know, it might be a few degrees out. So what I say is always keep on your calculator, keep your last answer. Well, it automatically keeps it on the answer button anyway. So keep those, don't round it off and press zeros and stuff. Okay, leave it as it is because we're going to use that entire answer. We're not going to use the rounded off version. Over, okay, let's get that pen one more time. So it's over 15. We're looking for the angle. So therefore on our calculator, we're going to first get a ratio by saying that side 46,478 and so on divided by 15 gives us 3,09857 and a few other decimal places. So this, once again, don't press the zero. You want that whole answer, 3,098 and some other things, but it is on the calculator. But thanks, Ty, for being away. All right.
No problem.
So if we want angle ADC, all we're going to do is on our calculator, our answer should still be there, right? 3,098. We want to get to angle ADC. We were using the ratio tan, so therefore I'm going to say shift tan. And then, guys, you're going to press the answer button because that answer means it's the previous answer that was on your screen. Okay. And that's going to give me an answer of 72,11. So once again, just rounding off to 2 decimal places. I get angle ADC is 72,11 degrees. All right. Okay, so this is a typical easy test question, but it is the basics that have to get you on the way to getting all those harder questions sorted. And you know that when you're in grade 12, you don't just get given nice, easy examples with all the numbers given. You're going to also start thinking about your compound and double angles, and sometimes that comes into play. I don't think we've got an example with that today, but you've got to remember your compound and double angles can also be tested in this section. All right, we're going to go into the next example. All right, Todd, is there any questions on that first example that we've done?
No, I think everyone's just enjoying the show and following along.
Okay, well, that's good to hear, so we can move along. And obviously, if you guys have any problems, you will give us a shout on the page. Okay, so it says the sketch shows one side of the elevation of a house, and some of the dimensions are indicated on the diagram. All right, and these are all in meters, just by the way, because it's not given there in the question. All right, so it's the side view of a house. Now, when you think of a house, think about when you started drawing houses when you were a baby. When you first learned how to draw, you'd make a little triangle roof, a little rectangle body. That's basically that's the view that we've got of the house. Okay, so we've got a rectangular shape for the base, and then we've got a triangular roof. Okay, they give you all the dimensions. Okay, incidentally, what's missing on this diagram is that's 90 degrees. It has to be perpendicular, otherwise you would have a lopsided house. All right, so those are, G is 90 degrees and angle F is 90, which means that EG is perpendicular to DC and EF is perpendicular to AB. All right, before we look at the question, let's just have a look and see what we can mark down. Okay, we are given that angle D is 32. All right, we know that the length of DE is 7,5 meters, and that's about all we have in the roof section. All right, now if you look at the base, DABC or ABCD, right? Remember, it is a rectangle, so therefore, if side DA is 3,5 meters in length, then side BC is also going to be 3,5 meters. And if side AB is 9,4 meters, then side DC is also going to be 9,4 meters. All right, guys, so that's important because those little concepts will help us in questions later on. Okay, so we mark down what we can. All right, the first question says, calculate, and this time they tell you to 1 decimal place, and they want the length of EC. All right, so if we look at our diagram, EC is the other side of the roof. And so that's the other side of the triangle. That's the only side of that triangle, EDC, that is not known. Remember, we've got DC because we know what AB is. DE was given to us. So we're looking for EC. What is the quickest way to find it? Well, you've got two sides and an included angle. You're looking for the side opposite that included angle. So the easiest way to do it is the cos rule. Okay, so therefore I can say, right, and I'll have to refer back up so we get all the lettering right. So EC squared using the cos rule is going to be equal to DE squared plus CD squared, and then it's going to be 2 times DE times DC, and then cos of your included angle, which is 32. All right, so it's going to be EC squared is equal to ED squared plus, and I've got such a short-term memory, I can't remember, plus DC squared or CD squared minus 2 times ED times CD, and then it's cos of that included angle, which was 32 degrees. All right. So let's fill in all of the values that we have. So going back there once again, ED we got a 7,5 and DC was 9,4. So it's going to be 7,5 squared plus 9,4 squared All right, and then it's minus 2 times the product of the two sides. And then we're just going to squeeze in cos of that included angle 32. All right, guys, all of this you should do on your calculator. There's no need to do little itsy bitsy pieces and first square the 7,5, then the 9,4. It's just going to take too many steps. Okay, do everything in one step on your calculator. Okay, and I'm going to just move it over there. So we've got 7,5 squared plus 9,4 squared minus 2 times. So you're really just typing the sum in exactly as you see it on in your workbook or on your screen. And then it's cos of the angle, which was cos of 32. And that gives us 25,035. We're not going to round off at this stage, and it is important to remember not to round off at every point. Hey, you only round off at the very end. So it is 25,003, some other numbers. Okay, and then we want to find EC. So therefore, we have to take the square root of that answer. Okay, so it's going to be square root of that answer. And the answer is 5, because they said rounded off to 1 decimal place. So therefore, your answer here is just going to be 5 meters. So EC is 5. All right. Now that we've got EC, and this is quite a long one, they then want us to find angle DCE. So let's have a look at which one that is. DCE. So that's this little angle here. Okay, so what is the best way to find that angle? Well, let's have a look. We've got a 90-degree triangle now, so we could use that, but that might be a little bit complicated because we're going to need to find another side. But we've got an angle, we've got side EC, and we've got DE. So probably the quickest way to do this would be to use the sine rule. Okay, and it really just depends on your question. You can't tell beforehand what's going to be the quickest method to use. It depends on what you're given. All right, so for this one, it looks like we're going to use the sine rule, and I'm going to keep it on the top here. Hopefully it doesn't get too messy. All right, so here we're looking for angle C, and I'm going to set it out via the sine rule, 7,5 over sine of angle C is equal to EC, which was 5, we just worked it out, over sine of 32. Okay, I'm looking for angle C, so if I cross multiply, I'll get 5 times angle sine of C is equal to 7,5 times sine 32. Okay, so therefore sine of angle C is 7,5 sine 32 all over 5. Okay, so let's have a look. We're going to do this on our calculator once again. So we've got 7,5 sine 32 divided by 5. We're just using the 5 now because they said round everything off to 1 decimal place. We've rounded off our side EC to the length of 5. Okay, so it's going to be 7,5 sine 32 divided by 5, which is 0,79. All right, we're looking for our angle C. So what we need to do is we now need to use our second function button. So we'd go shift sine of that answer. And the answer there of the angle, 52,6. All right, remember we're rounding off to 1 decimal place. So therefore we'll get angle C is 52,6. Okay, so that's angle DCE. All right, and guys, you can see that most of the working is actually just done on your calculator, and obviously you've got to remember your sine, cos, and area rules, and you need to know when to use them. Area rules the easiest because you can use it in almost any triangle as long as you've got two sides and an included angle. All right. So we've worked out EC, we've worked out angle DCE. The next question says find the area of angle DEC. So there we go, our first area question. So we want the area of triangle DEC. Let's have a look. DEC, that's the one where we've been working with all the time. That's the roof of this house. So I would say, okay, even though we've worked out EC and we've got angle C, we've worked them out, and we could really work with either of the sides or the angles, it's usually safer to work with the information that they gave to you. So because they gave you side DE and side DC and angle of 32 degrees there, it's easier to use the area rule using side DE, CD, and angle D. So it's safer. Safer, not easier, just safer. Okay, just in case somehow you made a mistake and you messed up one of the sides. All right, so therefore the area of triangle DEC is going to be equal to, remember your area rules are half AB sine C, so it's a half of the product of the two sides. So a half of 7, 5 times 9, 4, and then sine of the included angle. And our included angle here was the 32 degrees, so it's sine 32. All right, and then once again, just put that on your calculator, and let's see what we get. So it's 0.5 times 7, 5 times 9, 4, and sine of 32, and that gives us 18,7, because we're going to round off to one decimal place. 18,7 meters squared, since these sides were in meters. All right, and that's the area of your triangle DEC. All right. Guys, we have to do the last part of the question, so unfortunately, even though we probably need to take a break because it's going on for so long, we have to just finish this off because they are related. Hopefully you can see that if you had the length of EG, which is the height of triangle DEC, you could have used a half base times height to find the area of the triangle. Because remember, you learned way back when in grade 9 that the area for triangle is half base times height. So if we had height EG, we could have used that formula to work out the area of triangle DEC. Okay, so we're quickly going to look at the last part of this question, find the height of EF. And in fact, it ties in with what I was telling you now. Because if you look at EF, it's the sum of EG plus GF. All right? GF is the same perpendicular distance between DC and AB as AD and BC. Okay, because they're all in the same. If you look at that, that distance has to be the same, otherwise your house would be lopsided. So therefore, if AD is 3,5, GF is 3,5. So that means the only thing I've got to do now is to find EG, because if I add EG to GF, that will give me the total height. There's different ways you can do it. You can work out EG in triangle EGC, or we can use exactly what I was telling you now. Remember, another way to find the area of a triangle, I'm going to try and slot it in here. Another way to find the area of a triangle is to say a half base times height. All right, now we know that the base of the triangle is 9,4, and we know that the height of the triangle is actually unknown. It's EG, so this one here, it's unknown. It's EG. So that is how you would find the area of a triangle. But we've just worked out that the area of this triangle was 18,7 meters squared. So therefore I can equate this to 18,7, and I can work out the height EG just by dividing a half times 9,4. So therefore EG will be a half times 9,4, work that out and say 18,7 divided by that. All right, so 18,7, we've already rounded off, so we're going to divide by 0.5 times 9,4. And that's going to give us 3,97. If we round that off, we're going to get 4. So therefore, EG is going to be 4 meters. All right, guys, and I will explain just now using the heights and the, the other formula. I'll just re-explain it for you guys. But you could have also used the 90-degree triangle to work out side EG. But now that we know that EG is 4 and GF is 3,5, the whole length EF is going to be 3,5 plus 4, which is 7,5. All right, so guys, what we did is we used 2 ways to work out the area of the triangle to help us to find the height of triangle DEC. But as I was saying before, you could have just worked within one of your triangles. So for example, you could have worked in triangle GEC and then worked out the side using your 90-degree triangle. But what we did is we used a half base times height will give us the same answer as the area, and then we use the area that we had just worked out. So usually if your questions link into each other, especially if they're hence questions, it's quicker to use what you've just done, which is exactly what we've done. All right, so it is quite a marathon of a question, this, and these questions can be quite long, so I'm sure that you are all just ready for a break.
I think so too, because I'm looking at it, I'm like, wow, that's a lot of information.
It is.
But on that note, Mindsetters, do not disappear. Make sure you have your pens and pads out because we'll be right back after this break.